So in lesson 92, we talked about symbols of inclusion. We talked about when we have a problem with parentheses, maybe even brackets with parentheses inside of the brackets, how we would take care of the innermost section first, the innermost set of parentheses or brackets first, and then work our way out. There's another type of inclusion symbol, or I should say it's a symbol of inclusion, but it's kind of a symbol of separation as well, and that is the fraction bar. So this is the bar that separates the numerator from a denominator within a fraction. So we're all familiar with a numerator being the top and the denominator being the bottom. As we go further and further into algebra, into the higher maths, you're going to see more and more complicated fractions where you're going to have operations that occur within the numerator and operations that occur within the denominator. And it is going to become more challenging. And what we're going to do is we're going to solve one side or the other first. We're going to treat it like it's separate entities. So we will condense and solve as much of the numerator as we can, and then we'll condense and solve as much of the denominator as we can. So our order of operations will then be to simplify within the symbols of inclusion first, then to simplify exponents and roots, and then to multiply and divide in order from left to right, and then add and subtract in order from left and right. So PEMDAS. But to that, we want to add that we will do those by side of a fraction. So let's just jump into 93.1, and I'll show you what I mean by that. So let me write it up here. So here we have 93.1, and you can see this is a complicated, a long expression in the numerator, and then we have a complex expression in the denominator. There's no way that we can just look at that and reduce that fraction the way that it is. So what we need to do is attack this fraction by doing the numerator, solving the numerator first, and then we'll solve the denominator. So let's attack the numerator first, and we can actually take it one bit at a time. So I am just going to start with the parentheses first. We have 4 minus, and within the parentheses we have 3 minus 7. So it's going to be negative 4 plus, and then we have 3 times 2. That's going to be 6 plus 6. Okay. So we know whenever we have a minus sign outside of a parenthesis that should be a negative 1 right there. And that's going to be multiplication. So 4, and then we have negative 1 times a negative 4. That's going to be 4 and a positive 4. Then a positive 6 and a positive 6, right? So if we use our associative property, we can group the 6's and the 4's together because we know that 6 and 4 is 10. So if we take this 4 and this 6 and make 10, and this 4 and this 6 and make 10, we know that we have 20. So we can say that the numerator is equal to 20. So now we're going to look at the denominator, and I'm going to, actually I'm not going to erase that. I'm just going to move it over so that you still have that reference. We don't lose that. So now within our parenthesis we have negative 4 and a negative 1 to be combined. So that's going to be 2 times a negative 5, which is going to be the same as a negative 10. So we'll put negative 10 here. So now we have a positive, I'll go ahead and just put the sign right there so that it's obvious, a positive 20 over a negative 10. We know that when we have a positive and a negative or different signs together, that the answer is going to always be negative. So we're going to reduce this. First of all, we're going to divide by 10. We know we can get 2 10s out of 20, and we know it's going to be a negative. So our answer is going to be a negative 2. And that's how we would attack that. Do the top first, or you could do the bottom first. It doesn't matter as long as you put it in its respective location, its corresponding place, put the denominator's solution in the denominator and put the numerator solution in the numerator, and then do the division of the fraction as you normally would. All right, so let's look at 93.2. So in 93.2, we have a long numerator again, and then we have the denominator. So we're going to attack the denominator first this time, just to show that it doesn't make any difference which one you do first. 3, and then we have times, because we know that a whole number outside of a parenthesis means multiplication. 2 minus 4, so we know that's going to be a negative 2. So 3 times a negative 2 is going to equal a negative 6. So we're going to put that in the denominator, negative 6. And I'm going to move that over so we have that reference. And then we're going to solve the numerator. So here we have negative 4 plus 3, that's going to be a negative 1. So we have 6 times a negative 1 minus, and then we have a negative 2 combined with a negative 6. That's going to give us a negative 8. And then that is times 2. So let's do 6 times negative 1. It gives us negative 6. And we know we have a minus sign in front of this parentheses. So that's going to be a negative 1 times a negative 8. That's going to give us a positive 9. And then we have that positive 2 there. So it's going to give us negative 6. And then 9 times 2 is a positive 18. So when we combine these two numbers, we get a positive 12. So we're going to put that in the numerator. And again, a positive and a negative is going to give us a negative result. And we know that 2 times 6 is 12, so that's going to give us a negative 2 as our answer. So far we've had a negative 2 for both of our answers. So let's put up, let me see if I can get another one. You guys get the idea. I'm going to give us one of the problems from the homework assignment just because I want us to really get a handle on this. So let me put up 93.3. All right, so here we have 93.3, and we have two sums here that are being multiplied against each other, so we're going to have a product. So let's do the numerator first. We have 7 plus 3, that's going to be 10, times negative 7 plus 3, this could be a negative 4. Okay, 10 times negative 4 is going to equal a negative 40. So that is our numerator. So negative 40 goes here. And now if we look at our denominator, I'm going to, let's move this down out of the way over here. Let's look at our denominator. Our innermost parenthesis set of inclusion is going to be 11 minus 2 here, this parenthesis. So that's going to be negative 3 times 9 plus 5. And notice how when I get rid of a set of inclusion symbols, it's okay to change the bracket to a parenthesis because you only need one set now. And just a parenthesis is just easier to draw. You could just as easily have left that bracket and it would have still been just as right. So 9 plus 5, that's going to be 14. And a negative 3 times 14 is going to give you, let's see, negative 3 times 4. That's going to be 2. And I'm going to carry the 1. 3 times 1 is 3 plus 1. That's going to be 42. And since this is a negative and this is a positive, that's going to be a negative 42. So our denominator is negative 42. And I can reduce this fraction pretty easily by dividing both of these. So if I divide the top by, let's see, let's divide the top by 2, I get negative 20. If I divide the bottom by 2, I get negative 21. How about that? So I cannot reduce this any further, I do not believe, because this is an even number. And the only factors here are negative 3 and positive 7 or vice versa. But this is a negative and this is a negative. So the only thing I can do now is change this to a positive. And this becomes 20 over 21. And that is as far as I can reduce that answer. Remember, in algebra, in mathematics in general, Whenever you can reduce a fraction, do so. That is the right answer every time. And that is all we have for Lesson 93, and I will see you in Lesson 94.